Hey MCAS team members, it's Matt, obviously, and so I'm going to be showing you guys a video today on how to get an Airfoil's data points so that we can put it into ISOM so that we can do some analysis on it and get the coefficients of lift and drag out of it. So to begin, we need an airfoil that we want to test. So if you guys haven't picked an airfoil yet, I think the best site to get them from is airfoiltools.com. So go to airfoiltools.com, and here you'll see right on the main page there is an airfoil search. So we're going to click on that, and this allows you to search for airfoils based on a bunch of different parameters. So if you know the name, you can just type it in, or if you're not really sure what airfoil they use yet, you can search for airfoils based on their thickness, camber, group, and a few other things here to check out. If you have any questions about any of these things, come talk to me, or maybe I'll do a video on basic airfoil terms and how camber affects performance and things like that. But that's for later on. Right now, I think most of you guys know what you're looking for, and that's for a symmetrical airfoil. And a thin one at that, because thin generally means less drag. So, you can see here there's an option. It says symmetrical airfoils equals 0. So if we put 0 here, it should only bring up symmetrical airfoils. So we're going to put 0 there and search. And so it brings up all the symmetrical airfoils in their database. And there's quite a few. You can see there's over 14 pages of symmetrical airfoils. So I'm just going to pick a random one. And I kind of like the shape of this one. Not really, but we'll do it anyway. So the Epler 296, you just click on airfoil details right here. And it'll bring you to the page. And so here it has all the information about it, the maximum thickness and max camber. Camber is obviously 0, it's symmetrical. And another neat thing is it shows you a list of similar airfoils. And so you can preview them, see if you like the general shape, and if you do, you can check it out. Anyway, it also has a bunch of data. So it tells us what the coefficients of lift and drag are at different angles of attack and stuff. But the problem is that all this data is garbage. So we can't use this data, and if we could, this would save us a lot of time, but this is really the ultimate goal of what we're doing, is to get these coefficients. And the reason why these ones are garbage is that they're based on inviscid analysis. So that means no friction, which is not a real life scenario. So anyways, all we really need right now, if you like the airfoil, if this is one you want to test, you'll just take the coordinate points from right here. So select the first one, scroll all the way down, and copy them. Now, once you have them copied, you're going to want to open Notepad, and you're going to want to paste them into here. There might be a little indent here, just to save you a little trouble, just put an extra space there, and save the file. You can call it whatever you want. I'm going to call it Airfoil, and save. I already have a text file named Airfoil. I'm just going to replace it. And then you can close the file. Next thing you want to open is Excel. So I think I have Excel open. Yeah, here it is. So once you have Excel open, you're going to want to go File, Open, and get to the file wherever you saved Airfoil. So I just want to show you guys something. When you first open this, it's probably going to say all Excel files. So you probably won't be able to find your text file. So be sure to change this to all files. And there you go. There's my Airfoil text file. Okay, so there's this fancy little thing that pops up and it tells us like, hey, we noticed that your data, they call it, is delimited. And so basically all it's saying is that all your data points are in two columns. Well, do you want to keep it in two separate columns or do you want to merge them into one column? And so we actually want to keep it in two separate columns. So to do that, click on Fix Width here, press Next, and you'll see they put a nice little line between the two data points, which is exactly what we want. So you can press Finish, and boom, here it is. It has all your data points split into two nice categories, or two nice columns. And so I hope you guys know what these represent so far, but if you don't, just in case you don't, I'll show you right now. Each row of numbers represents a point, with the first column being the x-coordinate and the second column being the y-coordinate. And so once we plot all these on a graph, you get the airfoil shape of the airfoil. Sorry, whatever. You know what I mean. You get the shape of the airfoil. And so what we need to do is that usually these would be good to go. You could just plug them into the program, but our program's kind of picky, so they have to be in a specific format before we can plug them into our program, before we can do the analysis. So I'm going to go over all these steps with you, and once you know it, it'll be easy. It's just a little tedious at the beginning. So the first thing we want to do is we want to make sure that the first point in our data set is the point 1 and 0. And as you can see, we are way off. Now that's not because the data points are wrong, but really because they're in the wrong order. So you can see it starts at a number closer to 0, 0 and works its way up to 1, 0. So this doesn't always happen, but when it does, all you have to do is select both columns, starting with the left-hand column, select all the points up to 1, 0, and you can see there's more, but we only need this half up to 1, 0. And sometimes this won't be 1, 0, but it'll be very close. Either one will be the right one, like it'll be very close to 1, 0. So you'll be able to see it. Like this one's extremely close, right? And so if 1, 0 wasn't here, you would know that this is supposed to be the 1, 0. Anyways, I hope that didn't confuse you. If it did, just ignore it. There's a 1, 0. And then what you're going to want to do is sort it. So you click on Sort and Filter here. And so what it's doing is it's sorted from smallest to largest for the x. So what we want to do is sort it from the largest, which is 1, to the smallest. So we click on largest to smallest, and bang, it reverses the order for us automatically. So now we start at 1, 0. Perfect, that was the first condition. Second condition is that at the end of this data, up to here, it needs to end with 0, 0. So you can see this number is extremely close to 0, 0. It might as well be 0, 0. So we're just going to add 0, 0. So that's the second condition. It must end with 0, 0. Instead of adding 0, 0, you could always change these to 0, 0, these 2 points, but it doesn't hurt to add. So that's the second condition. The next condition is that the next point must also start with 0, 0. And so you can see again, it's very close to 0, 0. So if you wanted, you can make these 0, 0, or you can just right click on the right, insert, I clicked delete. Sorry, just right click, insert, and add the zeros that you need. And I'll just move these up. So the third condition settled. The next part starts with 0, 0. So let me explain briefly why this happens. So all these points up to here, and I'll color them in blue, are part of the top curve. And so they must start, the top curve must start at 1, 0 and end at 0, 0 of the airfoil. Now the bottom curve, which starts here, must start at 0, 0 and go all the way to 1, 0, which it already does. And just like I said, if it didn't have these points and it ended here, you could either add 1, 0, or you could simply make this point 1 and this point 0. So I think that's the fourth condition. The fifth condition is that both the top curve and the bottom curve have the same number of points. So if we look here, Excel is nice because it already counts for us. This first row doesn't count because it's not a point, so to make it less confusing, I'll just delete it. And so we have 1 all the way to 36. So we have 36 points in the top curve, and from 37 all the way to 73 we have the bottom points. And so 73 minus 36, so we have 35 points, I think. Great. Let me just do some quick math. Sorry, this is embarrassing, but 36. No, it says 36. What the? Oh, I put 72, that's why. Ah, no, we have 37, of course. So, we do not have the same number of points. We actually have an additional point in the bottom curve. So we need to get rid of one. It really doesn't matter which one you get rid of, as long as it's not the first or last one, because obviously we already said it has to be 1, 0 and 0, 0. So somewhere in the middle, doesn't really matter. Right click and delete one. And so you have 36 on the top. So if you have 36 on the bottom, it should go to a total of 72, which it does. So perfect. All 5 conditions are settled. Just to repeat, starts with 1, 0. The top curve ends with 0, 0. The bottom curve starts with 0, 0 and ends with 1, 0. Alright, so if I delete all this stuff I wrote on the side, the next condition is that the x-coordinates must have a comma after them. So this is why we're using Excel. There's a really quick, easy way to add a comma to the end of each x-coordinate. It's by typing equal sign. And whenever you type equals in Excel, it allows you to type out a formula. So we type equal, then you're going to click on the first cell here, A1, click the and button, double quotes, comma, double quotes. So all this is saying is that I want you to add, and that's what the and sign is for, whatever I put in double quotes to the cell A1. So when I click enter, you'll see it adds a comma to the first cell. So now what you can do is click on this cell and click on the bottom right hand corner and hold and drag it all the way down to the bottom. And you'll see once you let go that adds a comma to each and every x coordinate. Perfect. Now it also requires us to have a comma at the end of the y coordinate. So a really quick way to do that, now that you did the first column, is again to click and hold the bottom right hand corner and drag it to the right. And as you can see, it adds a comma to each and every point, y point. Now the program we're using to do analysis on these airfoils is a 3D program. So we not only need x and y coordinates, but we also need a z coordinate for the z direction. But because airfoils are two-dimensional, there is no z coordinate. So what we do is we just make the next coordinate 0. And another quick trick is that once you put the 0 here, you can just simply double click really quickly in the bottom right hand corner, and it'll fill the rest of the points with zeros for you automatically. Note there is no comma after the Z coordinate. And that's it. You are done formatting the points. This is the format they need to be with. Just to recap, starts with 1, 0, and the 0 obviously. We'll just ignore the Z, but starts with 1, 0, ends with 0, 0, starts with 0, 0, ends with 1, 0. Both top and bottom curve have the same number of points, commas after the X, commas after the Y, and Z is equal to 0. So now you can take all these points, select them all, copy paste them. So copy. And now what we're going to do is we're going to open up Notepad and we're going to paste them into here. So you'll see that some of the columns aren't lined up nice, like this guy right here. What is he doing? But that's fine, even though it looks messy. The program knows when the next point starts because of the comma. So you don't have to fix any of this, but if you want, you can, just to make it look nice. But don't worry about it. One last thing is before any of the points start, you're going to put a space at the top here, and you're going to enter the number of points in each curve. So there was 36 points in each curve. So you type 36, and this is why it's important to have the same number of points in each curve, because this number tells the program how many there are, and if they're different, then it won't work. So 36 points in each curve, comma, and then you're going to put the number of curves in this design or structure or whatever you're doing. And so because there's only a top curve and a bottom curve, there's 2. And there you go. So we're going to save this, and we're going to call it the name of the airfoil, which I forget. The E297. Alright, so I'm going to save this, file save as E29. Oh my goodness, what is wrong? E297. So save it wherever you want, and then you can close it. And now what I'm going to do is just going to show you what would be the next step. So really now you're done formatting the airfoil. But just to show you the next step, if you guys want to keep watching, what we would do now is open ISOM. Oh, I think I already, oh, okay. So you would open ISOM. And here I'll just show you, you go to File, Import Geometry, click on Formatted Point Data, which we just did, right? And now you're going to find the text file you just saved. So if I double click on my E297, and if I look at all the options it gives me, I want to import the points, I want to import curves. I don't need to import a surface because it's a two-dimensional object, so there are no surfaces. So I uncheck that. And approximation tolerance, you don't have to worry about this, but we'll just make the tolerance a little bit higher. And then click apply. And as you can see, the airfoil pops up. If I show the points, here are also all the data points. So you can rotate this, we can zoom in a bit more. You can see all these points are squished together, zoom in. Actually, you can keep zooming in. And you can see all the separate data points. So yeah, this is the first step to our analysis. Congratulations. If this doesn't show up, you'll know that you've done something wrong. So you just have to go back to your text file. Maybe you didn't enter the right number of points or something, whatever. But yeah, that's the first step. And like I said, uh, if you have any problems, you can email me, text me, obviously. Also, I might be doing a video on basic airfoil terminology and what to look for and changing what does what to the performance. But in the meantime, find some airfoils that you like, format the data points properly, and then we'll move on to the next step of putting them into ISOM, meshing them, and doing the analysis.